Welcome to the HeatWise tutorial on thermal bridging. So in this tutorial I'll be going over the thermal bridging feature in HeatWise, which is a new addition to the walls and roofs. So when you're in HeatWise, if you go to either walls or roofs, you can create your wall or roof types, and you will see the thermal bridging feature within those sections. So we'll start with an example, creating a wall type. And in this example, I'm going to assume that you already know the basics of the wall inputs and outputs and what they mean. If you're not familiar, you can see our wall and roof tutorial video on our YouTube page. But for now, while we go through this, I will assume that you know the basics, but I will repeat some information in case it's new to you. So we'll start off by just entering manual values here. One thing to note is that the thermal bridging, how it's computed, will be different depending on whether you use manual or build wall option for your wall type. However, the solar absorptance and wall weight will not impact your thermal bridging calculations. So once you've got your wall type figured out and you've done what you want, you can add a thermal bridge by clicking this button here. And you'll notice that you can just keep adding thermal bridges as you like, and you can delete them as you want. And each thermal bridge that you add becomes its own expandable section with its own inputs as well. Now before moving on, I'll just briefly explain what a thermal bridge actually is. So if you have a wall assembly and you have something in your wall that is not part of the typical wall assembly but can conduct heat usually faster than the rest of the wall, it's considered a thermal bridge. So it's a pathway for thermal energy to transfer through your wall assembly that will decrease its performance. So it'll allow heat to transfer faster through the wall than you would otherwise like. So a common example would be studs in a wall cavity where you have insulation. If you have a stud in there, then heat can transfer through the stud instead of traveling through the insulation, causing it to move faster through the wall. So it's parallel heat transfer between the studs and the insulation. So you can see in our thermal bridging inputs here, we have a few options. We can use manual or select by material, and we have a few options here. So we'll start with the basic ones. So manual entry. This is the R value that you would want to enter for the bridge itself on its own. So let's say you have a thermal bridge and it has an R value of 2. So whereas your main wall assembly without the thermal bridge, so just if there were no thermal bridges, your regular wall would have an R value of 20, and on its own the thermal bridge has an R value of 2. Then you also need to give your area fraction. So this is the percentage of your total wall area that's going to be taken up by the thermal bridge. So for an example, if you have a stud that was 1 inch thick and it runs the entire height of the wall, and it occurred every, let's say, 10 inches, then it would take up 10% of your area. So you would enter 10 here, and that would be 10%. So for example, I'll just enter 5% here. And what it does is it takes our R value, our area fraction, and our initial R value, and we get an output of an adjusted R value here. And in this case, we had 13.79. So thermal bridge with an R value of 2 that takes up 5% of the wall area decreases our total wall R value from 20 to 13.79. So if we increase this from 5 to, let's say, 8, you'll see it automatically updates, and now we have an even lower R value because that thermal bridge is taking up more total area. Whereas if we put 5, you can see it raises back up because now it's not as low of an R value. It's closer to our original. We bumped it up from 2 to 5, so it doesn't have as much of a negative impact on the net wall R value. So although manual entry is the easiest, you won't always have the R value of your material at hand, so you can also use the select by material. And you'll notice we have all the same material options as when you create a wall by material, so which we'll get to in a minute. But for example, let's say we had a thermal bridge and it was a wood stud. We could select woods, and let's say it was maple and it was 3.5 inches thick. Now it's important to note that this thickness value is in the direction of the thickness of the wall, and it's not from facing the wall. It's a cross section of the wall. What is the thickness that this occupies moving through the wall? So we'll put 3.5 for example, and you can see it calculates our R value. And again, we can enter the area fraction as a percentage, or we can actually use a recurring stud option because this is very common. So it may be easier to just add your recurring stud. So let's say this stud was a 2x4, so it's actually about 1.5 inches thick and is every 16 inches on center, and we would get an area fraction of 9.38%. So it just calculates it for us, and you can see it computes the R value, the final R value in the exact same way, just that it has these intermediate values populated for us based on these inputs. Now, one thing that's important to note is you don't need to know the area of the wall or how many studs or anything like that. Those inputs come in the spaces portion. So when you're creating your space, you'll give a wall area. So at this point, it doesn't matter if any wall of this type is 100 square feet of face area or 200 or 1,000. We're just simply giving the input of what percentage of that wall face area would be occupied by the stud. So when you add windows to the wall and it takes away some of the thermal bridges, takes away some wall area, this should never really change. It might change by small amounts, but you should be able to just keep the inputs the same. It's just a thermal bridge is something that is usually recurring, so you can kind of take any sample piece of a wall area and you'll get approximately this percentage of the wall being taken up by that thermal bridge. So I'll now go over how these inputs differ when you use the build wall option. In case you've never done this before, I'll just go very briefly over how this works. So when you build a wall, you can just add layers continuously. Some layers have a pre-built thickness and some don't, and you can always delete layers and add more as you want. So for example, we can add stucco on our outdoor surface, and we can then add for example gypsum board drywall. We can add insulation. Let's say we wanted just some whatever insulation, and we'll give these some values here. We'll say 1/2 inch thick there, and we'll say this was a 2x6 cavity, so it's a 5.5 inches thick. And we'll just add another layer of drywall at 0.5 inches. And you can see we get an output R value of 23.18, so it just calculates the R value for us, and it actually calculates the exterior wall weight for us as well, if you've never done this before. So, like I said, these inputs make no difference here. I'm just going to do this as an example. But one thing you'll notice here that this is also a new feature is the custom materials. So if there was a material you wanted to use but you didn't see it in the options, you can create your own. So these are some that I created before, but we'll just create a new one. We'll just call it ABC for now. You would give it an R value per inch. So you're not going to be able to specify the thickness here, but an R value per inch. Let's say it's 1.5 for this example. And density in pounds per cubic feet, we'll just say it's 3. I'm just making up these values here. We'll hit done, and you can see we can still have the option to edit this or delete it, and we can add more as we want, but I won't do that for now. And you'll see here that we have the option to use our custom materials in our wall construction if we want to. And now, if we go back down to our thermal bridge that we were editing before, you'll notice there's a few more inputs now that weren't there before, and that is the bridged layers. So you'll see 4 options here, and these are actually the exact same as our layers up here. So what we're deciding here is which layers our thermal bridge actually goes through. So which layers are going to be transferring heat in parallel with our thermal bridge. So if you look at this example, stucco on the exterior wall, well, if this is a stud, which we'll now say is 5.5 inches, because that's our insulation thickness. If we have a stud, it's never going to really be going through the stucco on the exterior wall. So we would unclick that. So now it's no longer bridging the stucco. The same with the drywall. It wouldn't be going through the drywall. It would be going between the two pieces of drywall, but not actually through the drywall. So it stops at the drywall surface. But in this case, we want it to be bridging our insulation. So the point of this example here is that we've got an insulation cavity, 5.5 inches thick in our wall, and that cavity is filled with insulation, but every 16 inches it has a 2x6 maple stud. And so that stud is bridging the insulation, but nothing else. And you can see here, it based on just that bridged layer, it calculates our output R value. But if we change the layers it's bridging, you can see that our output R value actually changes. So this makes sure that your R value output is actually very accurate based on which particular layers are transferring heat in parallel. And the last thing that I'll point out here is that while we created our custom material up here, you can actually use that for your stud or your thermal bridge as well. So we can use that material that we created here and it will change the R value outputs. So that is how to create a thermal bridge in HeatWise. So we just did that for wall type as an example, but you can do the same for roofs as well. It works the exact same way. Everything is literally the exact same, so you can do them for both and see how your thermal bridges affect your total R values of your wall and roof assemblies. So that's it for this tutorial. We'll see you in the next one.